Okay, on number 10, it says we have the equation x squared minus 4x plus 13 all equals 0. It says use the quadratic formula to solve this. So remember your quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So remember that your a is your first value right here, so a is going to equal 1. Your b is going to be your second value right here, which is going to be equal to negative 4. And c is going to be your third constant, which is equal to 13. Substituting those numbers in and solving them, we're going to have a negative 4 plus or minus the square root of, so now we got negative 4 squared, and minus 4 times a, which is 1, times c, which is 13, and that's going to be all over 2 times 1. Simplifying it down, you got negative 4 makes that a positive 4 plus or minus the square root of. Now simplify this inside the radical. So negative 4 squared is going to be 16 minus 4 times 1 times 13. So that's going to give you a minus 52. Now when I take 16 minus 52, that's going to be negative 36. And that's going to be all over 2 times 1, which is 2. Simplifying this down further, you can get 4 plus or minus, and the square root of negative 36 is going to be 6i all over 2. Now I notice there's a common 2 in each term, so make sure that you divide each term by 2. So dividing each term by 2, I get 2 plus or minus 3i, and that is your answer. So 2 plus or minus 3i. Okay, on this next equation here, on number 11, it says we have x cubed, and we've got plus 8x squared, and then you've got plus 11x, and then minus 20. So on this problem right here, it says it wants to go ahead and find the real zeros of the function. So here's all your possibilities. Your possibilities are plus minus 1. So the facts of the first term. All the facts of the last term, you got plus minus 1, plus minus 4, plus minus 5, plus minus 10, and I forgot my plus minus 2. I'll write it up there. And then plus minus 20. So now your possibilities are just your last terms, all of your first terms. And remember, the book calls this P, they call this one Q. And they say that all the possibilities are going to be P divided by Q. So P divided by Q, I've got plus minus 1 all over plus minus 1. I've got plus minus 2 all over plus minus 1. I've got plus minus 4 all over plus minus 1. I've got plus minus 5 all over plus minus 1. I've got plus minus 10 all over plus minus 1. And then I've got plus minus 20 all over plus minus 1. So these right here are all your possibilities. So now I got to go ahead and figure out which one of those possibilities, when I use synthetic division, is going to give me a remainder of 0. So what I do on this problem, so as I look at number 11 again, I want to use synthetic division. I just want to start substituting in that list of possibilities for those numbers. So notice I've still got my equation x cubed plus 8x squared. and then plus 11x minus 20. I'm going to write down all my factors. So I got 1, I've got an 8, I've got an 11, and I've got a negative 20. So I'm just going to go ahead and start substituting in those numbers. So I'm going to start with a 1 and see if I get a remainder of 0. If I get a remainder of 0, that means it's a factor. If I don't, then it isn't. So 1 times 1 is 1. So I got 9. 1 times 9 is 9. Gives me 20. And 1 times 20 is 20. That gives me a remainder of 0. So notice now I've got my equation of x minus 1 times x squared plus 9x plus 20. So I'm going to take that second equation, x squared plus 9x plus 20, and I'm going to factor it. Okay, so notice that when you actually take those out on number 11, you end up with your equation of x, and then you have minus 1 squared, or sorry, x minus 1 times x squared plus 9x plus 20. We go ahead and factor this equation again, so you end up with x minus 1. And you end up factoring the factors of 20 that add up to be 9 is 5 and 4. So you end up with x plus 5 times x plus 4. Now to find all the zeros, we go ahead and find the answer. 2x minus 1 is x equals 1. X plus 5 becomes x equals negative 5. And x plus 4 becomes x equals negative 4. And there's your answers. You got 1, negative 5, and negative 4. And this matches up with, it looks like, the answer of C. Okay, your next problem on number 12. Number 12 says I've got p of x, and then I've got the equation x cubed. I've got plus 10x squared. I've got plus 41x. And I've got plus 50. It says that one of my zeros is negative 2. So I'm going to use synthetic division. I'm going to write down the coefficients of 1, 10, 41, and 50. And since negative 2 is already in answer form, I'm going to take the negative 2 out of my equation. So bringing down my first constant, I've got a 1. I multiply, and then I add. I multiply, and then I add. I multiply, and then I add, and I get an answer of 0. So now I've got the equation x plus 2 times x squared plus 8x plus 25. Okay, now I'm going to go ahead and take a look at this equation here. So notice I've got x plus 2. I've got x squared plus 8x plus 25. So you're going to notice that this equation here, it's not factorable. There's no factors of 25 that add up to be 8. So I'm going to have to use my quadratic form. I've got negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, remember, looks like your a is going to equal 1. Your b is going to equal 8. And then your c is going to equal 25. Substituting those numbers in, I got negative 8 plus or minus the square root of, so I got 8 squared minus 4 times 1 times 25, and that's going to be all over 2 times 1. Okay, simplifying this down, I've got negative 8 plus or minus. Now 8 squared is going to be 64 minus 4 times 1 times 25 is going to be 100. So I got the square root of negative 36 all over 2. Simplifying this down further, I've got negative 8 plus or minus. Square root of negative 36 is 6i all over 2. I'm going to go ahead and divide every term by 2. And remember, it has to be all terms. Dividing this term by 2, this term by 2, and this term by 2. You're going to get negative 4 plus or minus 3i. So your 3 answers, in this case right here, is going to be right here, your x plus 2 becomes your negative 2. And then you got negative 4 plus 3i and negative 4 minus 3i. So there's all 3 of your answers. Okay, on this next problem, on number 13, it says it wants us to identify the quadratic function, the equation of the quadratic function of the vertex at 4, negative 1. And then it says we also have our point that it passes through. And it says it's going to pass through 2 and 3. So if we recall, the vertex form of a quadratic function looks like this. It's f of x all equals a times x minus h squared plus k. So now h and k right here, these two numbers are your vertex. And so my first step is to go ahead and substitute in those numbers for my vertex. So substituting those numbers in, I got f of x equals, and then I got a. Now substituting in the negative 1 in place of my, 4 in place of my x, I get x minus 4 squared. And then I get minus 1. So now that I've done that, what I need to do is I need to go ahead and substitute in the 2 and 3 and solve it. So remember, this is an xy pair. So now I'm going to end up with, in place of my f of x, I'm going to have a 3. And then I got my a is what I'm looking for. My x is 2, so that's 2 minus 4 squared minus 1. Now solving this out, you get 3 all equals a. 2 minus 4 is going to be negative 2. And negative 2 squared is going to be 4, so that's going to be 4a. And then minus 1. So add 1 to both sides. And you get 4 all equals 4a. Now divide both sides by 4. And you're going to get a equals 1. Now that you know that a equals 1, we can go ahead and substitute that into our formula. So we've got f of x all equals, we're going to put in 1 for a. And remember, 1 times anything is just itself, so you're not going to actually see that a written in there. And so then you got your parentheses around your x minus 4 squared. And then that's going to be minus 1. And that'll be your answer. Okay, number 14. It says it wants to identify the polynomial that has zeros at negative 1. and at negative 3, and at 1. So the first thing you got to do, you're going to notice you're going to write an equation for each one of these answers. So this one becomes x plus 1 will be my equation. The equation for negative 3 would be x plus 3. And the equation for 1 would be x minus 1. Now for convenience, I'm just going to rewrite this with the x plus 1 and the x minus 1 next to each other. So I can go ahead and multiply those two together first. Because when I multiply two conjugates together, you have to remember that the outside's inside is going to cross out. And so I'm going to end up with a smaller polynomial that will make it easier to work with. So notice right here I'm going to have to use FOIL. So first, outside, inside, last. So I've got x squared for my first. Outside is positive x, or inside is negative x. So notice that is your conjugate. Those cross out, and your last is going to be minus 1. So FOILing those out, I get x squared minus 1. So now all I have to do is just take x squared minus 1 and multiply it by x plus 3. And again, you're going to use FOIL, first outside, inside, last. So for my first, I'm going to have an x cubed. Outside is going to be plus 3x squared. Inside is going to be minus x. And then last is going to be minus 3. So there's your equation of the polynomial function that would give you those answers. So that's f of x all equals x cubed plus 3x squared minus x minus 3. Okay, on this next problem on number 15, looks like on number 15 it's going to go ahead and give us a rational function. So number 15, we got f of x all equals, and then it says we got x minus 5 all over x minus 6. So your first step on this problem right here is to go ahead and find the vertical asymptotes. So remember, to find the vertical asymptote, you're going to take the denominator, set it equal to 0, and solve it. So I got a vertical asymptote at 6. Now I'm going to find my horizontal asymptote. So just as a reminder, your horizontal asymptote, your rules are you're going to compare the numerator power with the denominator power. So you get 3 cases when you do that. You get the numerator power is less than the denominator power, which is one case. You can have the numerator power equals the denominator power, which would be your second case. Or your numerator power is greater than your denominator power. So if the numerator power is less than the denominator power, you know that you have a horizontal asymptote at 0. And I think Mr. Welch referred that as that you were bottom heavy. Now if the numerator power equals the denominator power, they both weigh the same. So in other words, your horizontal asymptote is just going to be the leading coefficient of the numerator. So you got your numerator leading coefficient all over the denominator leading coefficient. So it's just leading coefficient all over the leading coefficient. So the leading coefficient of the numerator, all over the leading coefficient of the denominator. Okay, and if the numerator power is greater than the denominator power, remember there is no horizontal asymptote. So in this case right here, you're going to notice that both these powers are 1. So that means that they're equal to each other. So that means that I'm going to do the leading coefficient of the numerator, all of the leading coefficient of the denominator. So here's my leading coefficient of my numerator, which is 1. All of the leading coefficient of my denominator, which is also 1. So this has a horizontal asymptote at 1. Okay, now I'm ready to graph this problem. So to graph it, you can go ahead and go to your vertical asymptote, which is what we found was at 6. So I draw my graph. So I go to my vertical asymptote at 6. Represented using a dotted line. My horizontal asymptote was at 1. So I come up here to 1. Okay, now I'm ready to decide which quadrant those answers are in. So I'm going to choose a number, and now in this case I'm just going to choose x equals 0. Find my y value that goes with it. So if you remember correctly, my equation was x, and then we had minus 5 all over x minus 6. So when I substitute in a 0, I get negative 5 for my numerator. I get negative 6 for my denominator. So at 0, it looks like I'm located at 5 and 6. Or sorry, 5, 6. So that would be that point right there. So I know that's going to be that basic shape in my bottom quadrant. Okay, now I'm going to come over to this other side. I'm going to choose an x equals 7. So x equals 7. I want to go ahead and figure out what that value would be for my y. So when I substitute that in, I got 7 minus 5, which is going to be 2. And 7 minus 6 is going to be 1. So at 7, I'm right up here at 2. So that must mean my basic shape is in my upper quadrant. And so that's what your equation would look like. On number 16, it says I've got h of t. And they give me this equation that says I've got negative 16t squared. And I've got plus 48.8t. So on this problem right here, notice it's a quadratic. So if you remember the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. If I use that entire formula, I find the x-intercepts. This right here wants me to find the maximum height. Well, your maximum height of any quadratic that is launched into the air always occurs at the vertex. Well, if I use the entire quadratic formula, that gives me the y, or the x-intercepts. If I just use this part right here, negative b all over 2a, that is the x value of my vertex. So I'm going to go ahead and substitute in. So here's my b. Here is my a. Substituting into that formula right there, I get negative 48.8 all divided by 2 times negative 16. Now if you type this in your calculator, make sure you put parentheses completely around your denominator, you're going to get your answer incorrect. So I take negative 48.8 divided by 2 times negative 16, which is negative 32. It looks like that I'm going to come up with an answer of 1 point. Let me check my calculator here real quick. So taking negative 48.8 divided by negative 32. Looks like I come up with an answer of 1.5. So notice that is the x value of the vertex. That's how long it took to get to the vertex. So now to actually find the maximum height, what I'm going to want to do is I'm just going to want to go ahead and substitute that in. to my equation. And when I substitute it in my equation, that will be my maximum height. So now substituting in 1.5, I got negative 16 times 1.5 squared plus 48.8 times 1.5. I put that into my calculator and it's going to come out to be, it looks like 37.2 feet. So that will be your maximum height. Okay, on this next problem, on number 17. Number 17 says it wants me to go ahead and divide and write the result in standard form. So it says I got 3 plus 2i. All over, it says I have 9 plus 7i. On this problem right here, when it says divide, it actually means it wants you to rationalize your denominator. The reason why we have to rationalize is because the I represents the square root of -1, and I know that I can't have a square root in my denominator. So I'm going to multiply both top and bottom by 9 minus 7i. You multiply by its conjugate. So remember the conjugate is 9 plus 7i is 9 minus 7i. The conjugate is like half and opposite. So when I multiply this out, I'm going to have to use FOIL for my numerator. So I'm going to take 9 times 3 is 27. Outsides is going to be negative 21i. Insides is going to be plus 18i. And then your last looks like it's going to be minus 14i squared. And I'm kind of running out of room here, so I'll just put a little squared sign up there. So I'm going to go ahead and simplify that. So I got 27 and negative 21i plus 18i. So that looks like that's going to come out to be a negative 3i. And remember that we had that minus 14i squared here at the very end. I'll write it in here so we can see a little bit better. But remember, I squared is equal to negative 1. So that's going to change that to a positive 14. So when I actually add 27 plus 14, so 27 plus 14 is going to be 41 minus 3i. Okay, now let's go ahead and do this denominator here. You're going to remember we've got to use FOIL, first outside, inside, last. But in this case right here, 9 times 9 is 81 for my first. Outsides, insides will cross out. You'll notice that's negative 63i plus 63i is 0. And that's going to give me a negative 49 I squared. So again, remember I squared is equal to negative 1. So that's going to give me 81 plus 49. Now 81 plus 49 comes out to be 130. So now I've got 41 minus 3i. All over 130. So now I just have to separate out the real with the real, the imaginary with the imaginary, and I'll have my answer. I got 41 over 130 minus 3 over 130 I. Okay, on this last problem, on number 18, it says it wants me to find the square root of negative 24. And then we've got plus the square root of negative 150. Okay, whenever I'm taking and simplifying radicals, I just have to remember my list of radicals. I know the square root of 4 equals 2. Square root of 9 equals 3. Square root of 16 is going to equal 4. Square root of 25 equals 5. The square root of 36 is going to equal 6, so on and so forth. So whenever you're simplifying radicals, you're just checking to see if any of those numbers can go into that radical evenly. And so I notice first off the square root of 4 goes into 24, so I'm going to separate this out as the square root of -1. The square root of 4 times the square root of 6. Now this next one, I notice that 25 can go into 150, and that's going to go in there 6 times. So I'm going to separate that out as the square root of -1, the square root of 6 times the square root of 25. Okay, now I'm going to simplify this down. The square root of -1 is I. Square root of 4 is 2I. I have the square root of 6. Plus, now the square root of -1 again is I. Square root of 25 is going to be 5. I square root of 6. So now that I notice my radicals, the imaginers look exactly like, I can add them together. 2I squared of 6 plus 5I squared of 6 is going to be 7I square root of 6. And that is going to be your answer.